Okay, so what I want to talk about today is the intermediate value theorem, and this is actually our first theorem that we're going to be using in calculus, and a very, very important one. So the intermediate value theorem states, let f be a function that is continuous on a closed interval a to b, and f of a cannot equal f of b. If n is any number between f of a and f of b, then there is at least one number c in the open interval a to b for which f of c equals n. Okay, that's a lot of math talk, and I know you're kind of familiar with that. But basically what this means is that if we have a function, like, and here is a, well, actually a would be here, but here is b, and our function goes like this, then there must be some value c right there within our function that equals, that exists. F of c is equal to n, so here f of c would be n, right? So basically it just says if we have a continuous function that every value between points a and point b are going to be met and reached. And that makes sense, right? So imagine if this was a person on a diving board and they dive, right? There they are, upside down. They've dove in, whatever. If you do a dive like that, then you're going, at some point in time, you're going to be at every single position here in the dive, right? And that's exactly how these functions work. And you can think of the same thing with like cars driving. You know, if you start at 0 and you get up to 60 miles per hour, at some point in time, you will have reached every single speed within there. You can also think of it as your actual own growth, right? So you started at a certain length, like maybe 22 inches or something, and now let's say that you're like 65 inches tall. Well, at some point in time, you were every single one of those heights in between, right? So let's go on to our example here. Apply the intermediate value theorem, if possible, on the interval 0 to 5, so that f of c is equal to 1 for the function f of x equals x squared plus x minus 1. Well, the first thing we have to do is this continuous. Okay, we've got x squared plus x minus 1. Yes, that's continuous. It's a parabola. I don't know exactly what it looks like, but we know it's continuous. Is it f of a equal to f of b? Well, that's what we need to find out. Here's our a, here's our b. So I'm going to calculate f of 0 is equal to 0 squared plus 0 minus 1, which just equals negative 1. And f of 5 is going to be equal to 25 plus 5 minus 1, which of course is 30 minus 1, which is 29. So f of a does not equal, f of b. So, good, we've got our second condition met. So now, is there a number c, pause. So, sorry about that. Is there a number c that exists for f of c equals 1? Yes, there is, because we know that our function, so there exists, I'm going to say, there exists a value c where f of c equals 1 because f of x takes on every value, f of x takes on every value from negative 1, which is less than or equal to 1, which is less than or equal to 29, on the interval 0 is less than, c is less than 5. And actually in this case I can say less than or equal to because I had closed brackets up there. So yes, we know that somewhere, some point in time, f of c is going to be equal to 1 on this parabola between the point 0 and 5. And if you graphed this, you could actually trace that and find what that is going to be. All right, let's move on to our second example here. We want to use the intermediate value theorem to show that f of x is equal to, x cubed plus 2x minus 1 has a 0 in the interval 0 to 1. Well, first we have to say, is this continuous? Yes, this is continuous. That's our first most important thing. It's continuous everywhere. Next, we have to find, is f of a equal to f of b? Well, f of a, which I'm going to rewrite. Why did I put a there? I should put 0. F of 0 is going to be equal to 0 plus 0 minus 1, which equals negative 1. And f of 1 is going to be equal to 1 plus 2 minus 1, which equals 2. So f of 0 does not equal f of 1. Good. That's our second condition met. Okay, since f of 0 is less than 0, right, and f of 1 is greater than 0, there exists a value c where f of c must actually equal 0 by the intermediate value theorem. And that makes sense, right? So if I've got this, I don't know exactly what's going on here with this function, but at some point in time, it's less than 0 is negative 1, right? And 1 was 2, so here, so 1, 2. At some point in time, I don't know what's going on. I don't know what this value is, but I know that there is a 0 that exists. And that's what the intermediate value theorem tells us, and that's what it explains. All right, questions? Bring them to class. Look forward to seeing you.